Assalamu alaikum. Dear students, let us understand the concept of determinant of a square matrix. Let A be a square matrix. The determinant of A is defined as that A is equal to determinant of matrix A is equal to determinant of elements A, B, C and D. That is equal to first entry is obtained by the product of principal diagonal elements A times D minus second entry is obtained by the product of other elements B times C that belongs to real number. Square brackets denote the matrix. The vertical lines denote the determinant of matrix A. Example: let matrix A is equal to elements 1, 1, negative 2 and 3, then that B is equal to determinant of matrix B is equal to determinant of elements 1, 1, negative 2 and 3. That is equal to first entry is obtained by the product of principal diagonal elements 1 time of 3 minus second entry is obtained by the product of other elements 1 time of negative 2, that is equal to 5. Singular and non-singular matrix. A square matrix A is called singular if the determinant of A is equal to 0. Example: let matrix A is equal to elements 1, 2, 0 and 0. Then that A is equal to determinant of matrix A is equal to determinant of elements 1, 2, 0 and 0. That is equal to 0. So matrix A is singular. A square matrix B is called non-singular if the determinant of B is not equal to 0. Example: let matrix B is equal to elements 1, 1, 0 and 2, then that B is equal to determinant of matrix B is equal to determinant of elements 1, 1, 0 and 2, that is equal to 2, which is not equal to 0, so matrix B is non-singular. Adjoint of a matrix. Adjoint of a matrix is obtained by interchanging the diagonal entries and changing the signs of other entries. Example: let matrix A is equal to elements 1, 2, 3 and 0, then adjoint of matrix A is equal to matrix having elements 0, negative 2, negative 3 and 1. Adjoint of a matrix A is obtained by interchanging the diagonal entries and change the signs of other entries. Multiplicative inverse of a matrix. Let M be a square matrix. The multiplicative inverse of M is defined as M inverse is equal to adjoint of a matrix M over determinant of matrix M. In first we find determinant of matrix M is equal to determinant of elements 2, 1, negative 1 and negative 3, that is equal to first entry is obtained by the product of principal diagonal elements 2 times of negative 3 minus second entry is obtained by the product of other elements 1 time of negative 1, that is equal to negative 5. Adjoint of a matrix M, that is equal to matrix having elements negative 3, negative 1, 1 and 2. M inverse is equal to matrix having elements negative 3, negative 1, 1 and 2 over negative 5. Hence M inverse is equal to matrix having elements -3 over -5, -1 over -5, 1 over -5 and 2 over -5.